Hello students. Today actually we are going to talk about a very common type of questions we will be getting in our MCQ paper. The capacitor type questions, the question types that we will be getting from capacitors. It's actually under electric field, of course you know that. So we are going to discuss the type of questions we will be getting. We are going to look at the past paper questions and let's find out what are the type of questions we will be getting from capacitors. So now if you work on it, if you have practice, if you have the skill to solve capacitor questions, students remember that we have to gather the questions from our MCQ paper. Now if you have studied really well, look into the question models you will be getting. So work on with each question model and you will be really good with the exam. Now you have to identify the question model and work for it if you have completed your theory. Even if you are not, this video will be very helpful for you to do capacitor questions. So let's get into the first type of question model. Parallel plate capacitor. Of course you know the equation capacitance of a parallel plate capacitor. That actually C, the capacitance will be A epsilon naught over D. That of course you know. The surface area and the medium inside of it, let's take it as a vacuum, and the separation between the plates is D. So C equals A epsilon naught over D. That of course you know, right? Then let's say another medium is inserted into it and half of its value, this half, right, is filled with a certain kind of a dielectric medium. So the dielectric constant equals K, right? So then we assume this, if we need to find the total capacitance, equivalent capacitance, we have to assume this as two separate entities, two separate capacitors. So capacitor 1 and capacitor 2. Right. Then the capacitors are there here one after the other. That means these two are in series, right? In theories, of course, you know, when capacitors, this again another theory, when capacitors in series, if we need to add them to find the equivalent capacitance, what do? We add them by taking reciprocal value, and then after that we take the other, we take the reciprocal and we find the final value. That of course you know, right? Then by using this method, let's find the equivalent capacitance of this second capacitor, right? So first one, the first capacitor, say C1, now it's equal to A, no change, K epsilon naught, that's a dielectric medium, and D, now it becomes half of that value, so it's D over 2, so 2 goes off, so C1 equals 2 AK epsilon naught over 2, right? So whereas in the very same method, C2 also will be, I'll write it down like this now. C2, of course, it will be 2A, there's no K, it's just epsilon naught, divided by, here we get D right here, it's D, so here we have D, right? Then in the this method actually we need to add these two, right? Let's find it. 1 over C equals, then take the reciprocal of it, so 2 AK epsilon naught and D goes off, plus again D goes off, 2A epsilon naught. Let's take the common denominator, 2AK epsilon naught, so it's D plus DK, so 1 over C. Now again C equals 2AK epsilon naught D, we can put the bracket 1 plus K, right? If it's an MCQ question, there must be a variety anyway with the answer, right? You cannot see the answer, right? So it's 2 AK epsilon naught D 1 plus K, right? This is the second method actually, right? The next one actually, it's like this. Now it's not clear, so I'll draw it again, right? It's moving into the third method. Now we can put the medium like this half, so that the area will be something like this, A half, and D will be the same. It's the same capacitor, right? Right. Now these two capacitors, now these two actually act as two different capacitors, capacitor 1 and capacitor 2. So if we put a cell over here, now of course you can see same potential will be applied for both. So that means these two capacitors are parallel to each other. Now you know, with theories, parallel capacitors, if you need to find the equivalent, C equals C1 plus C2. So you can easily add them, right? So let's write down the capacitance of C1. C1 equals, now area is A by 2, right? A by 2 K epsilon naught divided by the separation between D. That's correct. Right. C2, very same method, A by 2, just epsilon naught again D. Right. Now what we have to do is we have to directly add them. Right. So C equals here, I'll write it down, this one here, A K epsilon naught divided by 2D plus A epsilon naught divided by 2D. So let's say that we can take it out, A epsilon naught and 2D as well. In the bracket we will be getting K plus 1. Answer will be something like this, right? So we have done main 3 method, right? We can have lots of variations for sure, but I'm going to try another one. Let's see how that goes. Students, now the 4th method, actually we can, very same capacitors we used earlier, area is the common surface area and separation is the whole, everything is there. Now we can fill 1/4 of it like this. Okay. Now look at here. Now here we have how many capacitors we have here? We have one of course here, right? Let's write them down. We have one capacitor here, and we have another capacitor here, capacitor 2, and we have another capacitor here. We have 3 capacitors, right? Let's find out how they are placed actually parallel series. 1 and 2, one after the other, so it's series. So let's write it down properly. C1 and C2, right? And the third one is parallel to the combination of these, so it's like this, right? It's C. Now let's find out the values. C1, of course, it has to be, now the area is half of it, I hope you can see. So A by 2, and the medium will be K epsilon naught. Here now there's another change, the gap, it's D by 2 now. So D divided by 2, of course here you can see 2 goes up. So AK epsilon naught divided by 2D, again 2 goes off. Yes, you hope you can see 2 and 2 cancel off. So we'll be getting AK epsilon naught over D. Now we have C1. So in the very same method we can write down C2 as well, and C2 will be A by 2 epsilon naught D by 2, again 2 goes off. So A epsilon naught over D. Right, now we have these 2 values. And the last one, C3, will be A by 2 epsilon naught, it's not D by 2, it's just D. So A epsilon naught 2D. Right, now we need to add these. C1 plus C2, actually we have to add them in series method. So we have to take the reciprocal and add them. Let's take the reciprocal. 1 over C equals here this one. Here this one, right? D goes up, AK epsilon naught plus the other one, D goes up, A epsilon naught. So I'm going to take the common denominator here, AK epsilon naught. Right here up we have D, and here we have dk. Right, let's take the reciprocal value here. I'm going to take it up here. Let's take the reciprocal. AK epsilon naught goes up, and D common, I can take it as 1 plus K, that's C. So we have the answer, the capacitance of C1 plus C2. Now we know that value, right? Then students, we need to add this, right? It's these 2 are parallel, so we can directly add them. So what we have to do is we have to add this one, A epsilon naught 2D. Yes, you can simplify furthermore, but I'm not going to simplify it. Be my guess, simplify it, right? Okay, it's the 4th method. Likewise, there can be plenty of methods, but if you have masters these 4, I don't think you will face any difficult questions furthermore, because if you have practiced this, yes, any other varieties you can easily find out. Let's go for another type of question. In this question, we need to find the capacitance between point A and point B, right? In this question model, you can see the capacitors are connected by wires. Actually, I have done couple of questions from this model actually where resistors and capacitors are connected by wires and the potentials are equal in that scenario. So I have done a couple of short videos as well. So if you haven't watched them, go ahead and watch them and you will learn something for sure. Right, let's get into this question. Here, students, I'm going to name this point as point C. So it's connected by wire, same potential, here C. And let's take this is as D, so this as well D, connected by wire. So I'm going to redraw it just right. Okay, AC capacitor. I have a capacitor between A and C. First capacitor done. Second one, it's CD. Between C and D, we have a capacitor done. And the next capacitor, 5 microfarad, that's also DC, CD, right? So I'm going to redraw it again. I'm going to draw it again, like here it's 10, now it's 5, okay, between CD. And the third one, of course, that's also CD, in between CD, right? That's 9. And the last one, DB, it's between B, right? That is 9, 8. These three capacitors are parallel, of course, you can see it. So what we have to do is we can directly add them, right? So 10, 15, 9, 24. And here, of course, it's 12. So then these three capacitors will be in series. We have to take the reciprocal value and add them. So I'm going to take it as 1 over 12 plus 1 over 24 and then of course 1 over 8. The common denominator will be 24, 2 plus 1 plus 3. So 24 over 3 to 6. So it's of course 4 microfarad. That's the answer, right? Let's move into the next model. The next model actually it's actually connection of combination of parallel plate model and this wire connections, right? Let's get into the next one. Right, now here in this question we need to find the equivalent capacitance between point X and Y, right? So I'm going to assume we have a cell between X and Y, right? Just like the previous method we actually did. This is connected actually. I'll write with another pen. It's connected. P and S, these two are connected by wire, right? Now in this question I'm going to write the very same method. If this point is Y and this point also Y, because it's connected by same wire, potentials are equal. That of course we know, right? At the very same method, this point and this point, those two are connected. So I'm going to name this is P. So this point as well, it's going to be P, right? And this is Y plate, Y potential. So this has to be Y, and X potential. So this has to be X potential. So now I'm going to redraw the diagram. Capacitance of one capacitor, it has to be A epsilon naught over D. That of course we know, right? So I'm going to write from this one, the first capacitor, first one between P and X, right? So P, let's say X and P. Between X and P we have a capacitor, right? Then between X and Y we have one capacitor, X and Y. So let's say this is this point as Y, I'll take it as Y, right? Second capacitor. Third capacitor, of course, it's between Y and P. Y and P. So I'm going to connect it as like this. Between Y and P we have a capacitor. Fourth capacitor, of course, you can see again P and Y. So another capacitor that is parallel to this P and Y, right? The question, they're asking us to find the capacitance between point X and Y. Point X and point Y, right? If this is C, the capacitance is C from each, you can see these two are parallel to each other, so it's going to be 2C. This 2C and this one are in series, so we have to add them. 1 over C plus 1 over 2C, okay, take the common denominator 2C, so it's 1 plus 2 plus 1, so it's 2C over 3. That's the capacitance between these, right? Then we have to add this one. These two are parallel, so I can directly add them. So it's gonna be 5C over 3, right? Yeah, 5C over 3. Right, now we know the capacitance of one capacitor is C equals A epsilon naught over D. So the final answer, it will be 5 into A epsilon naught over D. That's the answer. Right, students, these are the question models actually I collected for now. So if you can see there are separate different types of question models from capacitors, please let us know so I can do that type of questions as well. But here the moral of this story, moral or whatever the message I'm going to give you here is that, students, if you feel like that you are good with certain theories, find out the question models that are available for MCQs. Even for essays you can try, but it's very effective when it comes to MCQ. So why don't you check your past paper book and find out the question models that are available. Now I have given you the capacitor type questions, PV diagrams, heat wise, resistor type questions, transistor type questions, the decibel, the intensity questions, Doppler's effect question models, that they can ask these type of questions. Because if you look at the MCQ paper, these questions are always there. So study from type of questions, question models, the varieties of questions. You will be a master if you can practice this one properly, students. So study and cheers.